Hey, welcome to this lesson on proportions in triangles. This lesson will go through some different theorems that we can apply to different triangles, whether they are right triangles or not. We can use these in all types of triangles to solve problems. First, I'd just like to review what an angle bisector is. The angle bisector of a triangle is a line segment that bisects one of the vertex angles. For instance, AP is an angle bisector of angle A, or BAC, in the triangle ABC. And the first theorem I'd like to talk about when we're talking about different triangles is called the side splitter theorem. Now what's going to happen is we're going to have a triangle, and there's going to be a line that's parallel to one of the sides of the triangle, and it's going to split the triangle. And so if that happens, if a line is parallel to one side, in this case RS is parallel to XY, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So therefore XR to RQ would equal YS to SQ. So if I look at an example of how we could use that, we might have a triangle that looks like this over here. And I might have to find a certain missing length or a variable, in this case x. So I'm going to set up the proportion pk to km is equal to ln, or nl, to lm. So what I'm going to do is I'm going to substitute the lengths in for each of those sides, and then I'm going to solve the proportion. I'm going to cross multiply and get 9x plus 9 equals 12x. If I subtract 3x from both sides, I get 9 equals 3x. Divide both sides by 3, and I get x equals 3. A corollary to that theorem, if three parallel lines intersect two transversals, so I have two random lines, and I have three parallel lines intersecting them, then the segments intercepted on the transversals are proportional. So in this case, AB to BC would equal WX to XY. And lastly, I'd like to talk about the triangle bisector theorem. This states that if a ray bisects an angle, so now we have an angle bisector, in this case AD, it's going to bisect CAB. That means CAD and BAD are congruent angles. Then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So, in other words, in this case, CD is proportional to DB the same way that CA is proportional to BA. And we can run through a quick example of that. What is the value of x in the diagram at the right? Well, x is the length of PS. So we can think PQ bisects angle RPS. So we can use the triangle angle bisector theorem to write a proportion. RQ to QS equals PR to PS. So I can write up that proportion. I can substitute the side lengths in. So I'll have 10 over 18 equals 12 over x. I can cross multiply and get 10x equals 216. Divide by 10 on both sides, and I get x equals 21.6.